Hi. Can you hear me? Yeah. Um, so I don't know about you, but today is public holiday. Not public holiday. It's holiday, but not public holiday yet. I mean, tomorrow is public holiday, and probably those of you are new to Hong Kong will ask why, right? Not today, right? Because I think this is a holiday in China, not here, right? The reason is being that Hong Kong people enjoy nice life, right? So that's why you have public transport actually go 24 hours tonight, so it's nonstop. So people want to have some drinks or whatever at night. Okay, so that is why today is not public holiday, but tomorrow because people drink and then will not wake up tomorrow for work. So that is the reason. But that being said, I don't know whether you feel happier or from the holiday mood, or you are not very happy because you still have to attend the class today. But I will try to make it easier and simple, and so that you don't feel too bad about having class today. So, and anyway, today's class is not terribly difficult. So it should be something that if you know consumer, then this thing should be something very similar. It's an auto optimization problem, but we step into two different steps. So they're showing you that solving the problem can be break down into two simple subproblem. So to recap what we have been doing, right? Topic 1 talk about consumer problem, where consumer maximizes utility subject to a budget constraint, or can be considered cost minimization problem, where consumer would try to minimize his expenditure to achieve certain utility objective there. Okay. And same here, we have two optimization problem, but they are not due to each other. One is called the cost minimization, where firm is trying to figure out how to combine his input to achieve certain production target. Okay, that means that it is firm's internal decision without regard to what happened to the market. Okay, so that means that regardless of market structure, this would hold. Whether you name game fee with the IO there's a supply chain that's unrelated. So that's a cost minimization. But then the next step goes to more is called profit maximization, is to take the market into account, right? Because at the end, the firm is going to make profit by selling, right? So, and that is a much bigger problem, right? This is only the internal environment, it's a cost minimization, but when you take outside, it's the profit maximization. So why we show you this, right? One, of course, this is a good way to summarize what happened when the market's competitive. But another way is because we want to show you that in economics, how we do the optimization or the solving the process in terms of sequencing by looking at internal and external, or the whole picture. So that is the way that it's not teaching you how to solve this particular problem, but how this problem solving method can be applied to your case. Right? Suppose you're talking about an organizational economics and managerial or problem. In that case, you may consider how firm internally organizes organizational structure, right? Which without regard to external factor. And then you can talk about, given the firm is already in the optimal structure, how it faces the outside, right? Because the two problems are related in the sense that if you want to do the bigger problem, you should also satisfy the smaller problem, simple problem, right? The reduced problem. So this is illustrated technique that how you can apply in the practice, and this is very often useful case, right? Because to reduce the problem is simpler, you solve it, and then you solve the bigger problem, right? And also you look at international trade model, right? They will talk about where the model there's no trade, autarky, and then the trade, so and so forth. This is a very standard way to reduce the problem. You shut down some channel, and you solve the problem, right? Same as why we assume in this model, right? We talk about profit maximizing firm. We talk, and in the way that there's no market, there's the market structure is perfect competitive, where each firm is a price taker in the product side or in the factor side. Why? Because we want to make the model simpler, right? We shut down some channel, right? The firm has no market power in the product market. The firm has no market power in the factor market, right? And in business world that a lot of firms has a market power, right? Say Walmart has a market power on his supply side, right? And because he buys so many stuff, right? He can decide the price, right? And say Apple, right, has a large of market power in terms of the product, right? If he charges iPhone $1 more or $10 more, $100 more, right? He don't lose too much customers, right? So that would be the idea. Lastly, the product surplus, which is a very minor notes on that, but this is something we want to learn. So as we said, firms are profit maximizers, and the firm is a black box. We don't study inside, right? Of course, I told you this is the first step, right? If you want to study inside as well, then you can divide it into two parts, right? So that would be, if you study organizational economics, that would be there, but we're not. But that being said, I want to here draw the similarity between firms and consumer, right? Consumer take an output and transform the utility through the utility function. And utility function, we have some structure, right? Convexity, all those kind of stuff. And here, the firm is transforming input to output. And it's constrained not by utility, but constrained by production technology, right? And this is something we can observe, then we can do it, right? Of course, if you study psychology, you can also see how consumer transform input to output is also there, right? If you learn behavioral economics and there's or neural economics, they will tell you how they being transformed. But here, this is what we have at the moment. Okay. So how to describe production technology? It turns out economists do it in a very simple way. Okay, it just described by a vector of numbers. Okay, the production plan is a vector, means number 1 to number m. Okay, and here is so simple. It's just like input output vector. Negative means input, positive means output. Okay, so it just doesn't tell you what, but this is tell you this is feasible. Okay, and m different types of input output can be labor, can be capital, can be time, can be raw material. Okay, can be anything. So when we write -1, 2 means I use 1 unit of item 1 to produce 2 units of item 2. This multidimensional, I use 1 unit of unit 1, 2 units of unit 2, produce 3 units of unit 3. Okay, these are the input and this output. Okay, and there's no limit to what you can output or can input. Okay, so this is classically they would call this, when you combine everything in the system, they will call the input output table, right? I mean, if you learn economics, that's classically done in the 1940, 1950. They look at this different industry, different input, and different output. And that was very useful, especially when people talk about planned economy, right? When the Soviet Union is there, that is something they collect a lot of effort to produce this kind of table, because they have to manage the economy, right? To say which area to produce what, and this is they do. Okay. Now, so what is feasible set, right? Is in consumer, the budget set is what is feasible. Here we have the possibility set, right? It's collection of all the production plan that give you the capital Y, okay, which is subset of M. Okay, do note that M is not M plus, because I now negative is input, right? So there's everything is there. Okay. So in general, this Y is a set. So if you look at the Max Colette, Winston Green, the classical book, they would make this Y very generic. Okay, you allow multiple output. But in our book, we do the Randy, and I think Jethill and Randy. The book we focus on is single output. Okay, allow only one output. But I mean, in most of the result, single output and multiple output are the same. Okay, and probably the reason why we do that is because we can reduce this to a single value function, right? Because only one output and multiple input. Okay, and then you can write production as a function, or otherwise it will be a set. It's a little bit more complicated than you can think. So, but this is more in line with your intermediate micro. So make our life easy. It's just n output and n input and one output, right? Same as utility function, right? N good produce happiness, everything positive, right? So that's why our life is easier when you have a single product, right? And in general, when you learn labor or you learn macro or undergrad, two factors are capital and labor, right? And then this will be our example. We'll keep the labor capital terminology for the rest of the chapter, but there's nothing stop you to go to n more than 2. Okay, and when you do empirical, usually n is a large number. And same as utility function, that actually we assume, right? Utility function is also continuous. We also sort of increasing this monotone, right? You increase your input, then you increase your output, same thing. Okay, and it's strictly quasi-concave. Okay, and if you remember what it means is if you have two possible input, okay, and suppose this one A and B, right? Suppose A produce more than B, right? Right. So there's certain combination of input with A and certain combination, say, maybe I have this 10 capital and 5 labor, say, right? And I have, let's say, there's another combination, maybe 4, 3, something like that, right? And suppose A is better than B in terms of output. Okay. Quasi-concave means you combine them. Any combination is better than the worst of the two cases. So combining cannot worse off. Let me repeat, okay? Under some input combination, say A produce output YA. Okay. Another input XB produce output YB. Okay. And then YB, you pick which one is larger, say, suppose A is larger. Okay. And you combine XA and XB, some combination must be better than YB. Is that clear? So some combination combining input cannot worse off. So that's complementarity. And we have that already, right? That gives you the convex set of the upper contour, right? Is how we draw the indifference curve, right? And same here. Later you see the isoquant is also like this. Isoquant is same as the indifference curve in production idea, but we'll talk about that later. But this will give you the standard shape when you learn in intermediate micro. And the only thing that is actually different from utility function, which is normalization, doesn't really matter here, is you can't produce something out of nothing. There's F0 is 0. If you have no input, then no output. But it is the same as saying in utility function, normalize to 0, right? If you don't consume anything, you're 0. But this is nothing very deep, nothing new here, right? Average product is simple, right? You just divide your production divided by how many quantity consumed is called average product. Okay. And of course, the key is still this guy, okay? The marginal product. Remember the role played by the marginal utility in consumer utility maximization problem. So marginal product later you will see will play a similar role in producer problem. Okay, is asking ourselves, suppose I hire one more unit of labor, how many more units of output it can produce? Okay, in terms of capital, maybe I have one more machine, how much more product I'm going to produce? Okay, and this will determine what's optimal, our optimal production plan. Okay, and probably those of you would wonder, okay, machine is not continuous, right? So how this model make sense? But of course, we usually assume F is defensible, and we will say capital, although it's discrete, but you can determine the time to use it. Right? Maybe you open it 24 hours, right? Or 23 hours or 10 hours. That thing can still be considered as continuous. Of course, it's approximation anyway. All right. So don't take it too seriously, but they do have the meaning. So as usual, then usually we assume, okay, because if I assume more than quasi-concave, we assume strictly concave, then we'll get diminishing marginal product, which usually you assume. Okay. The reason why being that if I assume this, we will not have in corner solution. We must have all the input will be used if we assume this guy. Okay. In general. So that would be guarantee you the interior solution. Now the next thing is same as you learn in a consumer problem. We have indifference curve. So you can expect the same thing as isocon, right? Indifference curve is the collection of the consumption bundle that is the same utility. So isocon is a collection of input combination with the same output, the same thing, right? Exactly the same thing. So we say all the input that give you the same output. Okay, the indifference curve is the same thing, right? It's this, but this is U equal to a U level, right? That's called indifference curve, right? ISO means the same quantity, right? And by the assumption that we make, it must be in this one, right? You go on the northeast direction, should be increasing in the quantity you produce because that is the monotone increasing, right? And the shape in this way is because of the strictly quasi-concave shape. Okay, and this will be 0 if you ever draw it. It will be 0, but you can't go further because you can have negative. So the isoquant is just only here. And it's slowly increasing, so this point is only the 1 point, right? 0, and then you can draw the rest. Is that okay? I mean, that is a fairly standard thing. There's nothing new to discuss here. Now, here comes the main thing. Remember, the key in the consumer problem, the FOC, will tell you what optimum condition is. The marginal substitution is internally how you think two goods can trade, make you the same. Same with the price ratio. Okay, here with something similar. Okay, and here is MRS is to your head. If I give up 1 unit of I, how many J I need to make me as same as happy as before? So M out, now T technical, is in technology, if I give up 1 unit of I input, how many J I need to put it back to make my production the same? Okay, let me repeat the statement again because this is so important. MRSIJ, right, in consumer theory is if I give up 1 unit of I, how many J I need to make me as same as happy as before? Here, I don't have utility, I'm production, right? Means that I give up 1 unit of input I, how many input J I need to make the production level the same as before, right? So it's internally, the firm, how it trade off two inputs, okay? Without worrying about the cost of doing it, same as MRS, right? We don't talk about whether it's feasible to do it or is it efficient to do it, but we just say, for you, how you trade in to keep your situation the same. Okay? And turnout is not difficult. It's just standard idea, just marginal product ratio. All right. Why? Just to explain again. If you're able to tell me, right? Because if I give up 1 unit of good I, right, then I would produce MPI of output, right? Because that is the uses of this 1 unit there. I give up 1 unit of input I. How much output I reduce is MPI, right? That's the marginal product. That's the definition. Then I ask how many J I would need, right? Then if I have 1 unit of J, I will produce this much. And I divide by that will give me how many units actually I need. Okay, exactly the same thing. Okay, exactly the same thing. So if you confused, then you can just write an example, then you will know. Okay. And turn out same as before. This is the slope or negative or slope of the isoquant. Okay, the indifference curve, right? The slope of the tendency is the MRS, same as here. Slope of the isoquant is the MRTS, right? Just to remind you, just the graph here, all right? So this is the one, all right? If you ever take a point here, you draw a tangency line, this slope will be the MRTS, okay? Of course, this curve is, this isoquant is different slope at different point. So every, the MRTS is defined by, at the point, right? Each point is different. Okay. So it's a local concept, right? Not a global concept, the MRTS. It's depend on the line that actually where you are. Okay, I hope this is clear, and this is the key of the model. Okay, because this is later you will see as we expect, right? The MRTS will be same as the input price ratio as optimal, right? Same as before, right? Before MRS equal to price ratio. Oh, because isoquant is negative slope. So, oh, negative become positive. Oh, because this is positive. So the slope is negative. So, I mean, if you don't like the absolute value, then make our life easier. Just absolute value. So, one thing that I mean may need to mention is a diminishing return doesn't imply diminishing MRTS. Okay, and what's diminishing return, which we will define later, is here. Okay. So production is slightly different from consumption. Okay. Because consumption, the utility is something is ordinal. Right. So you double the number, I mean the same thing, right? It's monotone. But production is a cardinal measure, right? How many output you produce is cardinal, right? And that means that there will be make sense not about return to scale. The idea is if you double the input, is it going to double your output? Okay. If it is, then it's just called constant return to scale. Okay. If you double the input, you produce more than double of the output, that's called equation return to scale. Okay. And if you double your less than, it's the equation return to scale. Okay. And in the classical economics, we will always assume it's the equation return to scale. Why is the case? Why we have to assume that? Of course, it's not always true, but why do we do that? If we have increasing return to scale, okay, there will be one problem: is Why we have so many firms? We have only one firm, that's the end. That's end of story, because increasing on the scale, right? So everything should be done in the big scale, right? Then we're done. No need to do anything, right? So you don't have multiple firms, right? But the modern microeconomics is written in a time where there's so many firms around the world, right? And that's why they end up with only thing division to scale, right? Cannot be have a big corporation is not going to work, right? And then you probably know the history of economic thought, right? It's only big corporation only exists in the 1900s, where there are a lot of subways and a lot of trains being invented in the US, and large country can be connected to each other, and a big corporation arises, right? Otherwise, I mean, they are not mega firm is not there yet, right? And also, of course, look at when the age of exploration, right? There's a big firm about the East Indian company, right? Those are big corporations, because when you do this kind of long distance trade, you actually have an inflation return scale, right? You have a small boat from Europe go to the India, it's not going to work. We have a very big boat, right? It's a inflation return scale, right? Because a huge fixed cost of a long distance trade, right? But in general, day to day, right, you don't have inflation return scale, right? Not until the time where you have whereby a monopoly arise, right? But before that is always decreasing the scale, right? Because since from B school, right, there's not something surprising to you. Something we don't model economics is human capital that is not easy to quantify, right? Usually manager has a limit, right? A manager can only manage as many as they can do, right? When you expand more than the manager capacity, usually they can't manage very well, right? And so there's a problem there, right? So that's why we assume classically that is decreasing return to scale. And probably you ask, now these days we have so many things that is decreasing return to scale, right? So that's why we end up with a lot of net monopoly there, right? Google is increasing return to scale, right? Because search engine, right? Once you have a good search engine with a nice algorithm, then you beat everyone, right? This naturally you have a natural monopoly, only one firm left, or a e-marketplace, right? Why you have one big firm, Tmall, Alibaba, right? Why we're one big, I don't know, taxi, right? DD, right? All of these are basically one firm can do most of the stuff. Or AI, right? ChatGPT, basically is the open AI do most of the stuff, right? When they have technology, then can invest so much money, then probably no one can even beat it, right? Because the huge cost in the huge fixed cost of the having the system there, right? Once you run it, the marginal cost is very low, so they will have increasing return to scale. So this very difficult for others to compete. But classically, we assume it's decreasing to scale that fit most of the I mean not most, a lot of the industry that satisfy this guy. And actually, when you see industry more than one firm, then you should be expecting decreasing return is at work, right? When you see the industry is featuring only one single firm, then more likely there's increasing return to scale. Okay. One thing that return to scale is related to what we call the very famous thing is called homogeneous of degree. It's a mathematical concept. It's a math concept. You should learn calculus. It's saying that when you multiply a constant to the input, you can take it out of the constant that raised to the power k. Okay, if this is called homogeneous of decay, this is the math concept. Okay, and if k is 1, it's called homogeneous of degree 1. Okay, and there's a constant with the scale, and by Euler's theorem, the math, That means that the one important thing is the marginal product is homogeneous in degree 0, right? You take relative respect to lambda, okay, and then that will give you the function, okay. And while you do that, if you do empirics, this is what you get, okay. The marginal product must be sum to 0. Now, the next is a very interesting result, okay, which allow you to assume f is concave, because when it's continuous, slowly increasing, 0, slowly concave, which assumes the new thing is homogeneous degrees between 0 to 1. So as long as not increasing return to scale, f is concave. Okay. Then when s is concave, f is quasi-concave, right? That means that everything is very nicely done, right? Concave means is we have the marginal product is diminishing, right? So everything is very nice. So that's why as long as you assume, as long as it's not increasing return scale, right? Lambda is less than 1, or equal to 1 is also okay. This is concave. So that is a very nice result. Okay? So that's why we can always start with the production function is concave, okay? Because this is what we assume. And that's a nice result. And we don't want to do the proof. If you want, you can take a run, you can look, but this is not something very deep here. Okay. And want to mention some standard example for production function, which I suggest you use it when you write your model. Same as we have perfect substitute and perfect complement and coplugulus with the same idea here. Perfect substitute is called the linear production. Okay, production is linear in 2 input. Okay, and you can calculate the MLTS. It's just the ratio of the coefficients. Okay, so this is very simple. But when you do contract theory, this is sometimes you can see that, right? Suppose firm rely on input of worker 1 and worker 2, right? And how do you motivate them to work as a team and so on and so forth? And this is a very standard function that people use it. And the other one is called Leontief, right? Is whether it's a perfect complement, right? It's a minimum of the 2. And this is also used in the team, in the production chain, right? Supply chain, this is very standard common, right? Because in the supply chain or in terms of organization, right, is how productive the system depends on bottleneck. Minimum of the guy is how fast you can. Like consider a factory, right? The production depends on the slowest guy, right? Because no matter how fast the first guy is doing, if the last guy is not doing anything very slow, then it's not going to work, right? So minimum is also something that is very fairly standard, right? When you talk about things in the network, right? Because the weakest link is the most important. The minimum is a shortcut to that, right? So that's not something like, although they're crazy, right? You may imagine, but it's very natural, right? Of course, one drawback is this guy is not defensible, but solving this is much easier than you think. Okay, so you can still solve this problem, but this MLTS is infinite, right? Because of there's no substitution is available. Now, last this one, if you learn macro, this is the most famous production function you learn whenever you learn macro. This is very standard. Macro, we only have 2, capital labor, and this is how people would fit. And historically, when you try to fit the macro model by capital labor, that is the easiest way to do. And this is what people do, right? And for capital labor, right, the alpha For capital is 0.3 and labor is 0.7, right? More or less like that. Okay. And this is the one that people keep using it, and that's the most useful one. Okay. And if you want the right model, you have the Cobb-Douglas function. I don't think anyone will complain. It's not general enough. This is fairly standard Cobb-Douglas production, and you use it when you try to write a model. Now we are introducing something rather crazy, and it is not so crazy because it is very similar to the thing we have. It's called the elasticity substitution. Okay, and this is very similar to the thing we learned before. Just let me take out the thing, although it looks super crazy. Okay, let me get out our chapter 1 slide here. We have something similar, if you still remember. So this guy is how change in MRS, change in the input. But you can simplify because of the optimality would equal to this, and that makes this one much simpler to do. But here we don't take this assumption, the same. You just change the price ratio. R is the input. How you change of the input ratio and change the MRS. Okay. And okay, put in this way. It's very difficult to interpret, but let me think this way. Remember, this MRTS is what? Is the slope of the isoquant. Okay, let me draw it, then you will have some better idea. Okay, and R is the ratio. Okay, so let's see. Let me try to convince you this is a measure like this. Okay, suppose we have a input 1 and input 2, all right? And we have an isoquant here. Okay. And suppose we fix this R. Okay? And R is the line where, right, is the ratio R, right? Because this is written as x2 equal to R x1, right? The simple algebra, right? And if you look at this line, right? Sorry, I didn't draw it rightly, but this is MRTS, right? MRTS 1, 2, and at this point, right? So what the substitution said is, suppose I change the red line by 1%. Okay, just mean rotate. Okay, suppose I rotate this guy. I rotate this guy by 1% means I just flip it a bit. Right? And I flip it. Okay. Look at the formula here. I change a little bit by percentage. Okay. And I want to look at, where am I? Of course, I will change my MRTS, right? Okay. I want to look at how big this change. Okay. Of course, how this change depends on how curved is the line, right? If it's flat, then this doesn't change at all, right? But if it's curved a lot, then this change a lot. right? So it's looking at, remember this is elasticity substitution, right? So how you change this ratio affecting the slope of this MRTS, right? Just change 1% of this, how you change the substitution between the two, okay? Of course, this is inverse, right? So it's how likely that you change, but it's measuring how curved this line is. I hope this gives you some idea what they're doing, but I'm not sure it is clear or you get more confused. But that is what it said, right? One percentage change in the input ratio, just to flip it a little bit, right? And how the slope actually changes, right? Just flip it a little bit, right? And how the slope change, right? And as I said, that is the idea, right? If the isoquant is flat, okay, and this is high, right? Because you take a lot to change, right? Otherwise, it's small, okay? And why you care about this? Probably you don't care about this at all, unless you do empirics. But the thing is, again, we will see this guy very, very often. Is this particular producer function, right? Cobb-Douglas is they multiply, right? And this one is the one that used very often, is adding each input to the power rho and times a coefficient, which coefficient sum to 1. You can ignore this guy, but sometimes we keep that, then you raise to the power 1 over rho, because I want constant return to scale, right? And this one is often used in the literature. Sometimes you will see in the literature they raise to the power a as well to make it decreasing return to scale. So instead of 1 here, they put a here. A is less than 1 to make it with decreasing return to scale. But this is the one that often you will see in the literature. Okay? You will see that all the time. Okay? And probably you ask why. One of the reasons why this is very common in empirics is because implicitly the production function is independent, right? How you measure one input has no bearing on the other one, right? Unlike Cobb-Douglas, right? If you measure one thing wrongly, you multiply, right? The other one would go wrong. But this one, if you measure one thing wrongly, it doesn't really matter anyway because adding, right? Of course, at the end with some impact, but it's not end of the world, right? But if you product Cobb-Douglas, then it's end of the world, right? Suppose one thing is 0, then everything is 0. But this one, yeah, it's not a big deal. I mean, there's something, but it's like it's okay. So, of course, if you learn macro IO, this is so common, and this is rather standard. You use it all the time, okay? And you know how to solve it if you work enough of this math. Okay? So I'm not going to prove the detail. Okay, but just to mention the same thing is they incorporate the linear production, Cobb-Douglas, and Leontief, the 3 as a special cases. Yeah. So since it's very convenient, right? Because you only need one parameter, rho. Of course, you also may need alpha, but that would be the thing that you need. Okay. And that is more flexible, right? If you're not econometrics, right? Because you have more parameter you can handle. Is that okay? So I hope it's okay for production function, right? The main thing is for this section is to introduce the CES production function, which is often used in the literature, right? And gives you the idea to draw the parallel from utility and production function. All right, you need to know, okay, now later you see when you have the cost minimization problem, you will not be surprised to see at the end the key is MRTS, right? The same. Later we'll see the MRTS will be equal to the input price ratio. That would be the idea, which we will do it after the break. So the break, which we will do very quickly, fairly quickly, is to give you the what we call the solving the cost minimization problem, and then we'll do the profit maximizing, which is also very straightforward. Okay, so we'll be fast after this one because I think we laid the foundation. We now draw the parallel between the consumer and the firm, and they're so similar. I just need to point out what's the difference. The rest will be relatively easy. Okay, we'll be much faster because I think we're too slow, and then these are too easy. So, but if you think I'm too fast, let me know. But let's a break. 15 minutes, and then we come back. So open and you reply in case you don't want to. You want to leave a message, but otherwise you don't need to fill in. You can have a break. I just open the break in case you want to ask anything. You say something, just leave there. Otherwise, enjoy the break. Let's see you 15 minutes later. In the meantime, I'm Gora to see if you have a question. So let's see how you tell me whether I'm too slow or too fast or so no one have done anything. That's good. So that means it's good. No news is good news. So let's continue. So don't worry, this is the part that you know where already. But there's nothing new here. So let's define problem. Okay. Now we consider after we talk about technology. So we want to talk about a problem that the firm faces to minimize cost. So we need to describe its environment the firm face. The first is price taker in the input. Input is called W. Wages, the idea wage, or you can use R, but I use the W. And by construction, price are positive. I think that is nothing deep here because they can be used to do production, so it must be positive. And same as the cost minimization for consumer, right? Which is minimize the expenditure such that production more than certain level Y, right? Same as minimize consumer expenditure, utility more than utility level, right? So exactly the same problem. There's nothing new, but just replace U by F as we said, right? And you will not be surprised to see the answer to this problem the same. Is that MRTS equal to input price ratio, right? Or the wage, the input price equal to proportional to your marginal product, right? So this result sometimes can be used as saying that wage is a measure of marginal productivity. Sometimes we use empiric, right? Because you can't really measure productivity, and you have wages, right? Different wages of different firm or different area, and wages will be the way to track different productivity, right? Especially it may not be good for the same different firm may use different technology, right? But if the industry is very competitive, every firm have similar technology level, then even between different industry, the wages of different job can be measured the productivity. Or within firm, right? If you try to say compare the wage of CEO and wage of the frontline staff, right? Then the ratio of them can be represented by the ratio of productivity, right? If you believe that this is the competitive market, right? So you can solve this Lagrangian, which you know how to solve it, I hope. So we need to talk about some very interesting thing, okay? That is slightly beyond the consumer result. Right here we have the well-known result, which is the input price ratio is the margin rate of technical substitution. Let me repeat why this is true. Before the break, we said MRTS is for the firm. At that point, keep the production the same. How many unit J you need to compensate the loss of 1 unit of input I? Okay, there's an exchange ratio to keep the production the same. So the left-hand side will be the external exchange ratio, which is you give up 1 unit of I, that give you WI money, and this WI money can be purchased 1 over WJ unit, right? So this is external exchange rate, right? To keep the budget the same, right? To keep your cost the same, right? This is how you exchange, right? You give up 1 unit of I, give you WI more unit, sorry, WI money, right? Then you can use it to purchase how many units of J you have, right? This is keeping the budget the same. So these must be the same. If not, then you do one way or the other, right? Because you change it, there's no financial consequence. To you, the same expenditure, right? Keep the same expenditure. You just swap. This is feasible, right? Next is, as I said just before, we write this FI, FJ, you just swap, right? So what does that mean? FRWI is what? FI is marginal product, right? And how much it costs? WI, you divide it is, if I spend $1, okay? If I spend on I, how much product you get, right? This, right? You spend $1, that's on I. This is a unit you will get, and this is unit I you get, then times the FI is how much output you can get. You should be same for product I or product J. Let me repeat the statement. If you add, you take one unit, you have one more dollar. Okay, you put an I. How much output you can get? This is the guy, left guy, and the right guy. So same, right? If not the same, you can take $1 out of one input, put the other, right? Because marginally, you spend the money, it should be indifferent between where you spend extra dollar. Otherwise, if you are optimal, you must be like this, right? Because you don't really care if you have $1 to spend or $1 less to spend, right? Then you should be the same. The thing is the same, you should flip, okay? You're flipping this will be WI over FI, right? WJ over FJ. So what does that mean? It means that if you produce one more unit of output, how much it costs, right? If you need one more unit of output, okay, you can do, if you want to produce one more output, you can produce through increased input I, okay? And how many input I you need is 1 over Fi. Times WI is the cost of increasing one unit output by increasing input I, okay? And it should be same for J as well, right? And that turns out to be lambda. Lambda is what there's a cost of increasing one unit output. That's an M.Phil theorem, right? The multiplier, right, is the cost of increasing one unit of output, right? The money cost. So that's 3 different ways to view it, and it's very useful when you do empirics, right? Because you can maybe measure prices, right? And then as a way they equalize, right? Then you can tell you can some way to measure this guy or measure this guy, right? Because this is come from, say, marginal cost, right? You can measure. You have this, they can estimate this guy. Right? Lambda can be estimated, right? Look at the marginal cost. Look at our garden data, right? You can have WI, WJ, then you can estimate the F, right? So these are relatively useful, right? Or in the factory, you can actually measure the marginal product, right, of 2 labor or 2 machines, right? You can calculate them, right? That should be, if you know one, you can know the other, right? Your capital labor. You may have capital, you don't have labor, but you cannot actually back out the FI. So some kind of thing can be useful in practice. Of course, in theory, it's still meaningful, but when the data is more fun. How can you make sure there is a solution that is something we have the existence of a unique solution, right? We'll assume strictly cosecant K, right? Because if 2 solutions, the middle one will be better, so that's why it's a unique one, right? And this optimal solution, which we call the conditional input demand, okay? Conditional because it's conditional on the y. Okay? Later with unconditional, there's no y. Okay? We'll talk about that when later, but this is conditional, is based on your input. This is how I produce. Why? Because we are solving a simple problem, right? Given the output y, this is our choice of input that minimize the cost. Okay, so we are solving a simple problem. Okay? Y is taken as exogenous here. Okay, so that is how you will solve the problem, right? Step by step, you solve an easier problem without taking account to the market. Okay, Y is a given. And graphically, this is not something terribly complicated, right? Because if in difference curves, budget line, the same idea, right? So you have seen that in the expenditure minimization problem, which I'm not going to elaborate further. And this one, probably the property what we have is only one. We just put here is called homogeneous of degree in the input prices, right? Which means that if you double all the prices, actually the same thing, right? Because remember the FOC, right? The FOC is what? MRTS equal to input prices ratio, right? The MRTS doesn't change, right? If you double the prices, the price ratio the same because you double everything. The relative price the same, so there's nothing changes. The solution remains the same, so that's a proof. Okay. And this is just the terminology, but nothing very new here. It's just saying that you increase your input, so increase your output. Does it increase your input? Okay, if that's the case, they call normal. If that is not, it's called inferior, right? Suppose you're producing papers, okay, and normal input may be computer, right? If you want to produce more academic paper, maybe you increase. The inferior input may be pen pencil and paper, right? When you actually produce more and more papers, you will use computer, use iPad. You don't really use really the real paper, right? Okay. So this example that probably you want to solve it on yourself. Okay. You take Lagrangian, you take FOC, right? Solve the problem, get this thing. Okay. You should study this on your own. I will give some similar thing in your assignment. Okay. That will ask you to solve the same type of problem, of course, maybe even simpler problem or something. Maybe gives you 3 inputs how to solve that. Okay. So you should be able to solve this type of questions. If I ask you to do this, remember what I asked for this class is the red one. Okay, the red one you have to know how to do it, then you're able to get very well for this class. Okay, of course, if it's good, you understand other material, but at least the minimum that I want you to do the red one. Make sure that you know how to solve them. You ask an assignment, of course, you ask the exam as well. But this is the main thing I want you to know how to solve it, because most of you are not doing theory anyway, right? So I mean, the main thing is to solve this kind of stylized model, and then you can put it in appendix for your regression, because these days often referee will ask you to have a stylized model at the end, right? And then you are not expected to write a deep model, and this kind of stylized model will do things, right? For example, let me give an example because I probably don't explain why you actually need this thing, right? You ask, okay, this is very standard. Why I would use it in my regression at all, right? Why we think we do that, right? The thing is, imagine you run a regression saying that there may be a factor affecting production function, say, suppose, right? Maybe audit, accounting student, maybe some more audit, right? Government impose some policy, do some audit, right? Audit may change production function or change whatever, change the cost, right? You add some parameter here, right? And then firm will do optimization, and you can see how that parameter you introduce change your thing, and then did reflect in the regression. That's what you do, right? Or you can think about supply chain disruption, and there's a text there, and then you add some change here, minor thing, and then you do the regret, you do optimization, you do compare statics, then you can explain your empirical result, right? So that's the reason why you need to learn the stylized model, because you will modify the stylized model, right, to explain your empirical result, right? Same here, right? You can, that is actually coming from when you do a project. That may be something you can do, right? Just look a stylized model like this, okay? And add something there, right? Maybe only now I only have one constraint, right? Maybe government constraint say, okay, you have to have X1 more than certain number, certain percentage must be X1, right? Maybe a labor law, right? When you hire local labor, you need to hire, when you hire foreign labor, you need to hire half of them are local, right? So on and so forth, right? You can add a constraint there. You can solve a couple different model, very similar. One more constraint, you have another result, right? And you can look at how this constraint changes the parameter, right? And look at how this and this can be part of your projects, right? You can solve this model, and there can be some empirical thing can be done. So this is something that you might be doing, or you have actually are doing when you do in appendix, right? Or you write a thesis, it's a long paper, right? In the appendix, you can put them there, right? That would be a good thing to add there. So that's the reason why, I mean, this is a required class for the for all of you, right? So you will write a simple model, right? You don't really need to think about, this Cobb Douglas, do I do worry? No, this is fine. I mean, you don't have to have a general form, right? But I hope this explains why I want you to know how to solve this red one, because in practice you may introduce more complication to it, right? As long as you know how to solve this, adding one more constraint or getting a more complicated potential function will be the same, right? Or there's a firm has more objective, more than minimize cost, has something in his mind, also can do. Okay, so hopefully you find this thing useful. There's nothing new. When you solve this problem, you plug it back to here. This is called the total cost function, right? This is what you learn in the undergraduate micro principle classes, right? Output cost function is usually you don't see W, right? You give you is, if you want to produce this much, how much cost you need to pay, right? And in undergrad, usually we start from here, right? We start from the cost function without telling you where the cost function comes from, right? So now we give the foundation how we derive the cost function, right? Same as why we need the first class, because we want to have a downward sloping demand function, the Marshallian demand, actually that come from utility or common preference even earlier. Now we tell you that the cost function actually come from this technology, F, right? The technology will give us an F, the C, right? And that explains maybe government subsidy, technology breakthrough can change this C, right? And then you can go on and do more stuff. But I hope that explain why what we are doing, right? Because it's very closely related to your empirical work. This is saying how you can calculate, right? Just put the number there, right? You put the conditional input demand there times this, then you're done, right? So there's nothing super deep here. Okay. The only thing deep, slightly deep here is this property of the cost function. You ask why we do that. The reason is usually when you do empirics, you start with this directly, right? Just start assuming some cost function, right? You want to estimate cost function, right? If you want to do that, right, then these are property you want to impose, right? And that help you to do estimation, right? If you impose some restriction, they're always direct. I'm not going to explain, but so the first one is very simple. When you output Y is 0, then the cost must be 0, and it's increasing in the W and the Y, yeah. And when the input price are positive, this must be slowly increasing. It's also increasing input prices. and homogeneous of 1 in W, which I explained already, because this is same as the reason is your input, the conditional input demand is the same, right? The XC, regardless of the price change, is the same thing, right? So if you double the prices, okay, you don't change the demand, okay? So basically just change the cost by double, right? Because there's no change in capital labor, there's no change in input. So that's why it's degree 1, right? Because it's degree 0 is XC. So that's why degree 1 for the total cost. Is that clear? Let me make sure you get it. Okay. Remember, this guy is degree 0. Okay. So mean double the prices has no impact on this guy. You double this, just double this guy. So that's why this function is xt1. Okay. So make sure that you know how to prove that. Concave in prices. So actually same as what we learned, the Hicksian demand. All right. So if you increase the prices, if you don't do optimize, it's linear. But you're smart enough, then you would have found a better substitute. So that's why it's concave. And here, that is something that, as I said, is a very useful, the Sapir's lemma. Okay, is if you look at the change in the cost over change in the price, you can back out the labor, the input of the object. Okay, so why this is important? It's because you have, we look at the financial firms, a public firm, you can look at the cost, production. You can look at the price, right? You can back out this guy, right? Because this guy you may not know, right? Because the financial data don't give you how many unit of water they use, how many material they use, right? You don't know, but if you're able to estimate the cost function, right? And you know the prices of W, then you can actually back out this thing, right? Fairly easily, right? It's not something too difficult to do it, right? Suppose, right, you have is public firm, you have many year costs, right? You have many year prices. You run the regression, right? You can estimate how they're linear related. The coefficient is by itself is the how many units they employ, right? So that is a very convenient thing, right? Anyway, so these are the red one. As I said, I emphasize that you should be able to do it on yourself. Okay, go home and try, especially tomorrow's holiday. You can try to do that. Maybe I'll release the homework later afternoon if you want to have fun. I mean, if nothing to do after the mooncake, you feel your stomach is very full and don't want to do anything, you can solve the FOC and try to plug in the number there and have fun. Don't worry. My assignment is much easier. We don't give you alpha. We just give you maybe from 3.4 and those more concrete number. You can figure that out. Okay. You need that because we actually need to solve, right? If you after this class you don't know how to solve this, it's my failure, not you. But you should be able to do it. Okay. Make sure that you should do that. I mean, even something that you should be able to do that. Okay. And that's very simple. You have learned that, right? You just over this average cost, you take the derivative, it's called the marginal cost, right? Although we do so many stuff, okay, very often we're just super lazy. In terms of, we say the marginal cost is a constant or even 0, then make our life very simple. Okay. But if you do something seriously, then probably you should not make those assumptions. Okay. Here I have a bunch of things that try to talk very quickly. Not very important, but just very quick. So if you learn the principal economics or the intermediate, they do talk a lot about short run and long run. Okay. How the firm, the choice of production, how do they cost is short and long run. The reason is being that short run and long run are just the planning horizon, not actually how long it thinks. It's just like whether you can think of things that can change, right? Suppose you're in CHK, right? The short run thing is basically you're here. You're not going to exit your previous program, right? You do optimization, it's here, right? You're not going to think about, okay, I go to US, I go to Australia, but that is after you done with the job market, done with your study here. You go around the world, right? So what can do within this 4 years, 5 years, stay in Hong Kong and do things, right? So when you think about what to do in the next public holiday, like tomorrow, right? You're bounded by the Greater Bay Area, right? But you think about ahead, like 10 years ahead, or you're going to have holiday in the Mid-Autumn Festival, you can think about Australia, you can think about UK, you can think about Europe, right? So it depends on the horizon. It depends on what thing is stuck, what thing is not stuck, right? Usually when you sign a lot of things, a long-term contract, it's stuck somewhere, right? So if you don't take long-term contract into account, right? Take it a constraint, right? Then it's short run, right? If you can change whatever you need, it's long run, right? Just depends on whether you take the constraint, existing constraint is binding or not, right? If they're binding, then it's a short run. Otherwise, long run, right? So suppose it's a marriage problem, right? Suppose you're not going to divorce or going to fire your spouse, right? Your boyfriend or girlfriend, then short run, right? If you get angry, just throw things to him or her or shout to him or her, then, or you don't do something or do something, right? You throw the vase or whatever, right? You scream, and then that is a short run solution, right? Long run solution will involve finding another partner, remain single forever, right? There are many solutions there. Or find another boyfriend, girlfriend, right? That's a long-term solution, right? So that is the distance. It's whether you take those things account or not, right? So that is the idea here, right? So that means that in generic, actually there's nothing deep in math, right? You're just saying the same problem, but some of the things are keep constant. You're not going to, it's not changeable, or at least you don't think about changing, right? That's very simple, right? Although in principal class, it takes so much trouble to talk about short and long run, but in math, it's very simple. It is says that this is not the part of the optimization. That's it. Actually, you're solving a weaker problem, right? Basically, just like instead of having a full problem, it's talking about an even smaller problem. That's it. Is that clear? There's nothing new there. Okay. Of course, there's some mathematical property to relate this short run problem to long run problem. I don't want to elaborate because none of you actually will use it. But I only want to mention one thing, right? Right? It's called the M.Phil theorem. Is if you have the average cost curve, okay? Maybe let me do that, right? The only thing that is worth saying is if you have this quantity or use y, right? I think I use y, right? The AC, right? AC. So what this important is suppose this is a long run AC. Long run means everything is changeable. Okay. And the short run AC must be within this set. Okay. So these are all tangency point here. Okay. This is all the other short run AC here. Okay. So this is the M.Phil theorem. This is the main thing that derives from that property, right? You learn this from the undergraduate, and this is actually come from the optimization problem. You can do the calculus, you can derive that, but I'm not going to talk about those because I'm pretty sure none of you actually use this. the proof is rather simple. And y tangent is just because of the M.Phil theorem. And also you can derive the same thing as the MC is cutting through the AC at the lowest point. Okay, but we can give economic intuition for that. Why? Okay, first, when MC is below AC, AC is decreasing. The idea is very simple, right? Because average, it is the same as your GPA. Okay, if your cost, your new cost, right? Suppose your GPA is 3, okay, which is B, right? If another course you take is C minus, okay, unfortunately, right? Then your GPA will go down, right? If you take other course which is B minus, your GPA keep going down, right? But if you take the course, you get B plus, your GPA goes up, right? So that's the same idea, right? So if your increasing unit, the MC is still below the AC, this is dropping, right? When they met and then go up, it's a time the AC pick up, right? So that's why you take, this is the area that your cost is worse than your GPA. This is higher than your GPA. So this is a fairly standard math problem. I'm not going to go to detail, but it can be proven, and I provide the proof already here, right? You just take the derivative AC, right? You derive that, that would be, you can get that. Nothing deep here. Okay. It would be something rather trivial if you see. Okay. I'm not proving that part. Okay. So we know the cost minimization problem. Okay, just to remind you, the optimal condition is marginal rate of technical substitution equal to input price ratio. Okay, because the internal substitution, same as the market prices. Okay, there's no way you can change, because input prices is you keep your expenditure the same, you exchange one to the other, right? What the financial outcome of the swap between I and J. And the left-hand side, MRTS is the real side, real outcome when you change swap I and J, right? This is production difference, okay? So now we are solving a much richer problem, is profit maximization. Okay? Nothing deep here. Probably you would not be surprised. It's a price taker. So PY is, if we produce Y, you sell P, P is constant, minus the cost, okay? Here we basically take price as exogenous, okay? Which means that the firm can sell as all the things he wants to sell, okay? Of course, this is unrealistic, right? But it's not difficult to change this one, okay? You can change it downward sloping, which we'll do it later. But at the moment, just assume that the firm can sell whatever it can be produced, okay? And it reached the production target Y, right? Your production no more than Y. And because F is monotone, so this one must hold at a constant, this inequality must hold, right? Because if not, then you can just reduce to make it whole, because it's costly, because W is positive, right? So you can replace this to become a unconstrained problem that even don't require calculus. That make it easier, right? You can see if I have this, right? I just choose input to maximize our production. So this is just standard optimization problem. There's no constraint. So that's the easiest in Fed, right? Actually, this model even easier than the cost minimization, right? There's nothing. Just choose X to max simplify. It's only solve the system equation without a Lagrangian multiplier, right? Even simpler. So this one, if you learn undergrad, there's nothing new here. You differentiate this equal to 0. The left-hand side, which is the first item, When we differentiate, this is the marginal product. Value of marginal product. Okay. Or marginal, they call the marginal revenue product sometimes. Okay. You increase 1 unit of I. This is how much product you can produce times the price is what's the value of the marginal product, right? Or marginal revenue product. Okay. And the right hand side is called the cost of having 1 more unit I, WI, right? So that is a standard idea called marginal benefit equal marginal cost, right? They must be equal, right? Because if this marginal benefit is higher than marginal cost, you hire more labor, right? Because you can always sell them at the price P. If you have the right hand side larger, then you should be reducing your production, right? By reducing I input, right? Because marginal cost is more than marginal benefit. So that must be the same. Okay. So that is a very trivial equation. I don't think we need to talk more about that. Okay. The only thing I want to remind you is, since it's so simple, we should ask ourselves the SOC, the second order condition. Is it the truly optimal? How can you guarantee optimal there? SOC is what? You differentiate this again respect to X, right? And this guy dies out. All you left is the second order condition, right? The second derivative of F respect to X, I, right? And as we assume it's a concave production function, this is a negative, so we're done, right? Of course, in general, you have to look at the Hessian, right? But we just assume this is fine, so you don't need to worry too much about that. Okay. So the idea is this, right? It's marginal revenue, marginal cost. Right? The marginal cost is the input price, which is constant. Right? You have 1 more unit. This is the cost, marginal cost. Right? The area below is the total cost because you integrate, right? And this is a marginal revenue product. It's a marginal benefit, right? So if you integrate this guy, this area is the total revenue. And you would hire until you get the heat, right? And of course, this area will be the profit, right? But that would be, this is the optimal point because once you increase, then you're losing money. So that's the optimal point here. This is clear. You can see this is, I don't have C here. This is the input demand, right? Look at the output prices and input prices. This is the input demand, okay, without C. Okay, this is how much you would want to hire input I to produce your output. Okay, this is the input demand. Okay, and the other way to look at the FOC is the following. Okay, you will write this into this form. The left-hand side is price of 1 unit being sold. Okay, so there's the marginal benefit of producing 1 more unit. Okay, what's the right-hand side? Right-hand side is the cost of increasing 1 more unit through increasing the input I. Right? If you increase input I, okay, by 1 unit, how much unit you need is 1 over the marginal product, right? This is how many unit I you would need, okay, is 1 over the marginal product, right? And what is the cost of having so much input is multiplied by WI, right? Let me repeat the statement here. This is 1 over the marginal product is how many good I you will need in extra to increase 1 output. keeping all the input the same. You just increase you just increase this unit input I to increase one more output, right? Let me repeat. If you want to produce one more output, right? How many input I you need, right? And times WI is the cost of doing it. So this is a marginal benefit, this is marginal cost, right? If right-hand side is more, right, then you increase the production, right? If you other way around, you reduce, right? So that's why it's always equate. So you can see, if you do some simple calculus, right, or simple optimization, right, it's very simple, right? Marginal benefit equal marginal cost, right? And if you have more constraint, the same idea, right? Just you have more terms, right, to explain, or more benefit to add. But you can see the formula would be the same, right? This kind of decomposition is very useful once you read the theory or once you have empirics. Okay, now you draw in this way, right? This is a marginal cost. This is the marginal revenue, and this is the output. Okay, so that would be the same, regardless of what we look at. If you do that, we still have this. If you remember this formula, right? You have I equation and J equation. You divide them. It's still the MRTS equal to input price ratio, right? Because the P will filter out, right? So that's how you get the same formula here. The MRTS is same as the input price ratio, right? So the same. So just make sure that what is you need, as long as you're willing to assume strictly concave, price is positive and input price is also positive, and then that will be a unique solution standard from calculus. And through this power function, we have two things. One is we have seen already. One is called the unconditional input demand, or input demand simply, right? How many unit of I and J, K you need, and how many output you're producing. So this actually gives you the same thing as marginal revenue for marginal cost, right? And this is the also marginal benefit of hiring one unit of I versus the cost of doing it, right? So basically you are solving the whole system at the same time, right? Because for a firm, you need to decide how many output to produce and how to combine the input, right? So this is your optimal production given Y, right? And this is given the optimal production, how you choose this thing. So this thing solves simultaneously. This depends on particular X. Okay. And this, right, doesn't depend on X, depends on W, right? Because this has no Y there. Remember, this what you solve is based on the cost there, right? Because Y only implicitly affect this guy, right? Affect where it is. So you shift back and forth. So some property, I don't think I need to talk too much about it. If you double your input price, output prices, nothing would change, right? The reason being, if you look at the problem, right? If you double this T, right? Math tells you just you can take out the T. No difference to the optimal solution, right? So that's double the input price, output price has no meaning. That means the inflation should then affect firm's decision, right? If everything increased by the same margin, right? But probably your business world, you know this is not true, right? Because It's often that now this is true in this case is the input price getting more expensive, right? And the price doesn't increase that much, right? So that's why people said the offline store is very difficult these days. Why? Because P doesn't increase that much, right? But the W increase a lot, right? So that means that why you see many places in the world, not limited to China, but everywhere in the world, it's very difficult to do an offline shopping store, right? Because the real shop actually have trouble of the squeeze, right? Because the price cannot increase because of competition, right? Price because it's so offline, the competition from online stores make the P doesn't increase a lot, but W increase a lot, right? Because your wages have been increased a lot, right? But look at your computer. I don't know, you go to your computer, iPad. Do they change the price? More or less no change. Look at your wages. The wages keep going, rising. So that means that firms are very difficult, right? But anyway, here's very simple computer statistics, right? If you want to output price increase, output will increase, right? And input price increase, your input demand reduce, right? Nothing very deep here, right? But you should convince yourself this is true and explain yourself why this is true, right? There's nothing deep in this. Proof is here, but I'm not going to talk about them, right? You should be able to do this kind of problem, solving this calculus profit maximization problem, which I will ask you to do it, probably do it today, or maybe I should try to do it after the class, and then you have fun during the mid-autumn holiday, okay? Don't worry, just 2 questions, okay? Just 2 questions. One for consumer problem, one for producer problem, so that's it. Okay, just solve some problem. Okay, you can solve this, the input demand and the output supply function, okay? For the time, I guess this is simple calculus. I don't think I don't need to go one by one, right? Just how you're solving this, right? In the rare case you don't know how to do it, just ask me. But otherwise, I would take it for granted you know how to solve it, right? Because it's that just take partial derivative x1 and x2, right? And just solve the system and put the number there, right? If you don't know, ask Mathematica, they should be able to do it. So here comes to the final function that we learned. It's called the profit function, right? Which is putting all the optimal value to here. This profit function, right? Nothing very deep here, but if you are from accounting, this is something you often look at the profit function. Right? Just try to explain. But of course, accounting may be focused on change the accounting rule in the information system, right? We change the F and how this translates to the profit, right? And of course, some of them will care about how the profit affect the market impact, right? The market price, so on and so forth. But that would be something that they will care a lot of time. Okay? And the profit function, we have some property like if you double the prices, profit double, not surprisingly. We look at the function, right? If you double that, you just take it out. So everything got double, right? Just look at this one, right? You double the W, double the P, you take it out, same function, right? Just, but everything multiplied by lambda. And the output price increase, you shouldn't be worse off. And input price increase, and they would decrease, right? That's what I said, right? Because now the P doesn't increase, actually sometimes reduce because Pinduoduo or those shop, actually the price keep going down, right? And the input price actually go up, right? Because the labor law or the inflation elsewhere that actually make the firm very uncomfortable. So these actually fit what we observe. Here there are something that I don't prepare to talk about, but you can actually check It's convex in price and convex in both input and output prices. Okay. The proof is you can do it somewhere not that difficult. It comes from the optimization idea, but I'm not going to talk about those. I don't think it's a very important result anyway. But one thing that is rather interesting is this M.Phil theorem. Okay. If you think the firm are optimizing, and if you estimate the profit function, when you differentiate the prices, you get back the input and output demand. Okay, this is also very useful because you can estimate profit because look at the profit of the firm, right? And you can look at the price changes, then you can kind of back out their input demand and output, which is you can observe, right? Maybe you can see why, maybe, but XI, the financial statement doesn't tell you, right? Right, but why you can see sometime. So, but you can back out this XI. So you can actually do this, right? You can plug in the number, you can get the profit function. So that's something that I would like to ask you to do as exercise. Okay. Just final note, okay? Before break, is how the profit maximization related to cost minimization, okay? And very often, okay, this is actually the two-step approach is something that we do most of the time is we will directly assume some cost function, okay? And that's a result of cost management problem, okay? And then we're trying to see the firm choose output Y to maximize this, taking the input price as given, right? So usually we'll take input price as given. So basically the firm is basically choosing Y only, right? Because X is subsumed, right? In that case, right, the problem is much straightforward because W is not going to change, right? So when you take the FOC, right, you will see is equal to price equal to marginal cost directly. So this is the one that actually you will use most often in practice because you will assume the firm will not, the input price are constant, right? So it doesn't really matter how it come to the cost function, right? Because you just write the input price, so you write the cost in terms of output Y, right? Maybe M is equal to Y squared plus 3Y, something like that, or just a Y squared, right? And then you just calculate this guy, right? And then you can solve the model. This is the one that used most often, right? Because usually computer statics or to solve the model, you don't really worry about the input prices. So this one is the one that you would do, and you also assume the total cost function is concave, right? Then everything will be done nicely. So this one, later you will see in game theory all the time. This is the one we do, right? Because why this is useful in game theory? Because it reduces the problem by thinking about the firm, it's choosing outputs, right? There's a Carnot game, and firm's strategic action, it just decide how much to produce, right? Or the price they charge. Just reduce things to single thing, right? Then our life is much easier. So this is the one that usually we take to game theory, right? Of course, if you want to, if you're not talking game theory, you can do more complicated thing, right? But game theory usually we do this kind of style. We assume the cost function, total cost function, is function Y, and just firms are maximizing based on this, right? This is the one, and W will be just forget, right? We just forget, right? So forget this guy, right? Of course, in game theory, the only difficulty is this P, right, will be determined by the market, right? It depends on how much the other firm is producing, right? The oligopoly model we'll learn in the second half of this course, right, is Why I don't produce as much as I want? Because I produce more, not only this P would goes down, right? Because downstream demand, but also you will create a chain of reaction from other firm, right? Just remember the OPEC, right? If I produce more, the other firm want to produce more, then the market price drop a lot, right? So that's why there's some toxic collusion happening here. Everyone try to restrict his output. But anyway, which we'll talk about game theory later. Okay. After the break, we'll talk about something mentioned about software in long run, and we will end. Okay. So after the break, we will have 10 minutes break, and then we'll finish this one and talk a little bit about equilibrium. Okay. Because the rest will be very simple already. I black out everything, so it means that it's not important anyway. Because that's telling you when the firm will shut down, when the firm will not, will leave the industry. That depends on the long run and short run consideration, same as the cost. Okay, so just the same that some factors are fixed, some factors are not. So there's nothing deep in the math. Okay, just some little bit tiny terminology or some change in the proof. But let's have a break and then come back. We'll finish the rest of the slides. Let me keep the you reply on in case you still want to fill in, but guess you can simply ask me if you have any anything you want to reflect on. That's around, go around. Yes. Resume. Get some water. Have some mooncake. Take some lantern. Again, no question, so good news. So what left is talk about some short run and long run because you studied with undergrad, people would tell you the same question is with a short run profit function and long run profit function, right? What we focus on long run because everything is on the table, but you can imagine that there's something you can't be in your thing, then those factors and the prices are fixed. So the same thing, right? Just say something, we just solve a simple problem because some input cannot be changed, right? So even easier problem. Although math looks messier, but the problem actually easier, right? Suppose your capital labor. Capital cannot be changed because they've been bought. Then they're there, you bought it, and then just change labor, right? Capital will mean the same. So that will be short run profit function. And probably you understand why this is the case, because firm can exit in the long run. Short run, they can't exit, right? So the short run is called the shutdown, right? So in the short run, they will set the price equal to the short run marginal cost, right? And you will see sometimes why some firms are selling at losing, right? When they lose the money, they still do it because they can't get out of it, right? They still do that, right? If you actually look at today's newspaper, I don't know whether you have that, but today's newspaper is they talk about there's a shop. If you have identity, this ID card have 10-0, you have 70% off. I don't know whether you read today's news. I guess especially for you. This is interesting. Actually, we to this. They have an identity card, 10 zeros, and then 70% off. News. Maybe. So this is actually, I saw it today's newspaper. I got there. I suppose everyone can be Chinese. So what it said is, they said you get the ID card. If you get 10-0 in your card, then you get 50% off. So there are too many people waiting. So people waiting like this. Okay. And what they can do, right? So they have announced the price so low, and they still keep doing it. Okay. And I don't know where you read this thing. So this exactly kind of fitting this, right? So they set the price so low. Okay. They still do it because price actually lower than the total cost. They stop the long run cost, but still keep doing it because price still higher than the marginal cost. They still do it because if you include the rent, include the salary, still cannot do it. 100%, but it's still higher than the food cost. Okay, they can still do that. All right. So I don't know whether you read the news, you can look at it. The news is very funny. And then you get, depending on how many zero you get 7%. If you get 3-0, then you get 90% off. Depending on how many zero you got. I look at your ID card. Not just the ID, because in the Chinese Hong Kong ID card, your name has the number as well. So each Chinese character has a 4-digit character, right? And then depending on month you have 0, right? Unless you're December, right? Look at your card. If you have 10-0, go there. I think it ends tomorrow. If you want to go there, and you can try to see if you can have a good discount there. But anyway, this explains why the firm doesn't shut down. They still keep doing, even though the price is below the marginal cost or average cost, whatever cost you can imagine, because they still want to do business. They still keep there, keep to tomorrow, and they still want to do it as long as doing the marginal benefit better than marginal cost. Even the total is losing. Right? So why some agreements still on? Because you cannot stay out of the agreement. So you keep going. Although you don't really like, right? It's like a standard thing, right? The girl, right, don't like the boy, right? And there's a very famous story. I think you read sometime, right? There's a girl who go to apply for exam for civil servant or for master or doctoral degree, right? And her boyfriend doesn't have a good education, right? Keep making money, right? And thinking that after she graduates, they can get married, right? And right, because they think that when they're there, because short run, so the long run is okay. The short run is making losers, it's fine as long as the marginal price, the marginal benefit cover the marginal cost, right? But of course, what he didn't know is the girl doesn't like her, right? After she got the civil servant job or he got to the master program, graduate from got the doctoral degree, he kicked out the boy, right? I think that's a famous story. I mean, more than one, multiple. Same idea here, right? Why the girl doesn't kick her out, right? Or the boy keep going because marginal, short run is okay, right? Still keeping not thinking I'll kick out. But once you figure out that, okay, she got a PhD degree or she got the civil servant job, then long run thing kicks in your head, right? I'm not saying the girl is a bad girl or the boy is a stupid, but this in the short run, you doesn't think so long term, right? Just this thing goes on, right? But once you get a job or once you get a degree, fixed degree, okay, things different, right? So it happens. Okay, so that's the reason, right? Try to explain, right? And explain why there's some shutdown in the short run, right? Why some you can imagine that is explain why in some shop, right? They all close on Sunday, right? Because Sunday is actually rent free, right? You pay the rent for a month, right? Salary also paid for a month, and many things are paid for a month. The capital cost, right? But they still shut down because it's below the variable cost, right? Look at manufacturing now, right? They don't have enough order, right? Instead of operating every day of the week, they only say work for 2 days and close for 1 day, right? Or work for 1 day and close for 2 days. Why they do that? Because of the variable cost, right? They don't do it because of variable cost, right? They don't exit, right? The same idea, right? So they open several days and close it, right? That kind of explains some of you, not some of you, but some of us, right? Are laid down, right? Why we lay down? Why we don't want to study? Why we keep watching TikTok? Don't work on your homework. Don't study. Why? Right? If you don't want to study, just quit the PhD program. Right? Why are you here? Right? It's because the price, the marginal benefit, right? Compared to the marginal cost of studying. You're still here, you're still higher, you're still there, but if it's below the AC, then you will exit, right? You still continue to study, it still pays you off, right? But at this point, you're so tired, you don't want to study, right? So the difference between AC and AC to AVC to AFC, right? The average fixed cost. So as long as things is still there, you're still worth your study. Okay. And I'm not going to talk about that, but just same idea, how the short run average cost and SMC, same thing, right? Because this is the AC curve and the MC curve. So I'm not going to talk about those. So finally, we just define one thing very simple. Producer surplus is simply the power function. There's nothing deep here because that is what it defined. And then because we define the firm is carrying this profit, maximizing profit, so there's a producer surplus. And this exact measure, right? There's nothing compared to consumer. You have the change in prices. You change any policy. How the firm will be changed is just changing price, changing profit, because this is objective of the firm, right? This is different from the case where Marshallian demand, right? Because when you talk about producer surplus, consumer surplus, is look at consumer demand, right? Look at the area under the demand curve. But that is tracing the change in utility, right? But here we have a direct measure of profit function. So that's done. We don't need the direct. We don't look at how the number changes. That is how the profit changes is how the firm's being affected, right? We can't do so for the consumer because we can't observe utility. So what we can do is look at the demand function, right? Estimate demand function, and then look at changes in the consumer surplus as a measure of changing the consumer surplus, changing utility. So that's why the difference is we can't really observe utility. So we have to rely on estimated demand and backward and go down and do that. Okay, because CV and EV, we can't really look at that. We can't absolutely observe equivalent variation or commensurate variation. We can somehow estimate consumer surplus. That is why we have that. But producer surplus, we can have exact measure, which is the profit. Okay. So which is area, if you look at the calculus, right? It's M.Phil theorem, right? Then just integrate the supply curve, right? So that's why the left of the supply curve is the surplus, right? Just the standard thing. This is the producer surplus, right? And this is the profit by itself, right? So that is an exact measure. Compared to consumer, this is not exact measure, this is exact measure. Okay, let me briefly review what we have done so far, right? We do all the firm stuff, okay? But this is very straightforward because it's the same as consumer, almost the same, I would say, right? But of course, you make different assumption on the firm production technology, okay, in order to get the same structure as consumer, right? Of course, some people will complain why with decreasing return. Yes, decreasing return is an issue. That's why we have monopoly and we have oligopoly. There's some issue there, right? But consumer, we don't have that, right? We don't have multiple consumer, this kind of theory. But for the firm, there's a more complicated thing, right? I mean, when you're increasing return, but you have multiple firms competing, there's no issue, right? We can have everyone is increasing return to scale, but when we have multiple firms competing, you don't have problem. But a single firm, there's an issue because a single firm will monopolize the market when you have increasing return. So there's some tricky part here, but because of we want a perfect competition, we want every firm to price sticker in input price, output prices. So this is only compatible when you have decreasing return to scale, right? But if you learn macro, when you learn network economics, when you learn supply chain, when you learn the real world, a lot of things are increasing return to scale. So that will be fine, but you have to introduce something to make sure everything is inconsistent, right? Because perfect competition is consistent with many small firms, decreasing return. So when you have increasing return to scale, you have to have some oligopoly, right? Or otherwise you have monopoly, right? Then you will have no problem. So you face a downward sloping demand, then you have no problem at all. Okay. I hope this is okay. Because the math is very similar and things are very similar. So I think it's okay that I don't go into every detail of the proof, because I want to save time to talk a little bit about equilibrium, because we're slightly behind the schedule, but I think it's okay. So equilibrium, we will talk about, as you see here, we will talk about something, how firms compete in perfect competition, which we have already there, but we just combine the first two lectures so far. Consumer and firm give you perfect competition. That would be something standard. You learn the Marshallian cross. And then we have monopoly. which tell you the case where actually fit the most cases when you have increasing return, right? When you have increasing return, we have one monopoly. Okay. And then we go to some classical IO model, the Carnot, the Bertrand, and monopolistic competition. I would say if we do apply work, this model, Carnot, Bertrand, and monopolistic competition is the thing that you use most often. Okay. And probably some of you know, look at my paper. Actually, I've written more than 5 to 6 papers based on Carnot only. I just do the Carnot model and derive many results. And sometimes I Bertrand, but even this baseline model can do a lot of stuff. And monopoly, I do a lot of some paper I have monopoly, and that's a good approximation. But some of you may worry, hey, monopoly, yeah, it's a good model, but doesn't fit the real world because always there's a new entry, right? But monopoly is an approximation, right? Just no need to worry about competitor, right? If you try to model, say, Apple, you can imagine Apple is a monopoly, right? At least within his own domain, there's no problem to model Apple as a monopoly. And it's a good approximation. If you try to fit a model there, it's fine. You consider how Apple do his stuff, it's a good monopoly, it's a good assumption there, right? As long as you think about how Apple make various decisions, it's a good approximation. Because we don't want to worry about competition, right? And for those who learn marketing or accounting, a lot of time you assume there's no competitor, right? The competitor is just normalized by some outside option, right? And there's some constraint represented by the competition. So monopoly would be good if you really want to model the competition, you can model by some constraint, right? Maybe the price cannot be higher than that amount, right? There's a competitor that's selling at this price, right? As long as the price is not above, then people will take it, right? Or you can imagine the model of a, say, Big Four in accounting world, right? Basically, it cannot, right? So that would be how you can do it. Okay. And after this, we'll shortly talk about the general equilibrium. If you are from finance department, this is the thing that you will do for your asset pricing class, right? Because asset pricing, if you look at the textbook, the theory, basically it's just a general equilibrium model and how the assets price being determined simultaneously, right? Because in partial equilibrium model, it means that some prices remain exogenous. For example, we will say about the market for apple, market for orange, okay, we can find equilibrium, okay? But we will keep the price for the soil, price for fertilizer, price for some other market is exogenous because we think that those markets are not relevant for our analysis, okay? In that case, we just solve some market and ignore our other market, then it's partial equilibrium. But when you try to solve all the markets simultaneously, that's general equilibrium. Or put in stock market context, if you try to solve the equilibrium price for one single company common stock, that is partial equilibrium. When you actually try to solve the market for bonds, for the stock, for the option, for the derivative, for all the things together simultaneously, that's general equilibrium. And that's general equilibrium you need, right? Because you are not only satisfied with single stock, right? Multiple stock at the same time, right? That is right, the CAPM model, right? The part of it, right? Is CAPM is try to solve this, right? Particular CAPM model, if you learn, right, that is basically assuming everyone have a same utility function, right? Everything is symmetric, what kind of market allocation you would got, right? But still they look at all the consumer, right? All the stock prices together. So some restriction, but this is general equilibrium. So let's get started. Because this is something that we combine the consumer and the firm with the same model that help us to understand what we're doing. Okay, but this is very simple. There's nothing new, but mathematical way to present the cross in the demand supply framework, right? Consider one good, and we look at all the good consumption, production, and price are constant. So that is why we call partial equilibrium, because there's no spillover effect from this market to the other. Okay, and now consider this particular good, high price is P. Okay, and we will assume first perfect competition. Perfect competition means that everyone is small enough. You wouldn't think, no one would think his action would affect the market. Okay, the important part is not whether they will actually affect the market. Okay, it's whether they think they would affect the market. Okay, and they're small enough that this realization, what they do actually doesn't affect. Okay, so that is important. And here, when I talk about the market mechanism or the market system, the price is the adjustment tool to equate the demand supply, right? To make the equilibrium, which means that firms are happy to produce what they're supposed to produce, and consumer at that price don't want more, given this good and trade off the other good, right? So there's no one want more or less given the price. Okay, so that would be the key. And let's start with some notation here. So we have I consumers, each consumer has YI income, and we will have the Marshallian demand, QIP YI. So this is something we learned, right? This is a utility maximization problem. We give you this one, right? The demand, different price, and income. Right? If you forget, let me go back to this one. That is very important. You remember why we're doing here is this guy. All right. You see it, right? What indifference, bunch of indifference curve, the budget. See. Okay. What you do is I change the price of good one, keep changing. I can trace this, that is the Marshallian demand. Okay. This gives you this one, right? By construction, you know this QI should be decreasing in P, right? Suppose the P goes down, Q goes up, right? P goes up, Q goes down. Okay. And whether this Q is increasing in Y or not depends on its normal good or inferior good, right? If inferior good, then Q is decreasing in Y. If normal good, Q is increasing. Okay. But QI should be decreasing in P. Okay. But do note that the YI is the income. Okay. And if you add up all the consumer in the system that come up with the aggregate demand, okay, this is the demand function. Okay. Do note that the demand function depend on price of the good, but vector of income, not sum of the income. Okay, so that is the very famous quotation that is turned out to be false. In the 80s and 90s, where Deng Xiaoping announced open door policy, where China opened up to foreign investment, at that time, people in Hong Kong would think there is a huge golden opportunity to do business in China. The one famous reason they said, China have at the time 1.2 billion people. Okay, and they would say, if every one of them give you $1, then you're 1.2 billion, right? Even though you earn $1 from each of one, right? So it's a huge opportunity. What's wrong with this statement, right? So, right, what's wrong with this statement? The statement is wrong is assuming $1 means the income, right? The thing is, it's not the aggregate income, it's the distribution of income, right? And our previous premier said, right, more than half a billion people in China actually earning less than $1,000, right? But it's now, right? Look at 30 years ago, how much people would be willing to pay $1 to your product, right? So it's not the aggregate income, but rather the distribution of income. Okay? So same as a marketing, right? That's important because when you run the regression, it's not about the aggregate income, but the distribution of incomes. When you try to estimate this demand function, right? Or people, right, would be worrying about how the distribution of that, right? It's not about the aggregate, but the distribution. Okay? Of course, it really depends on you view the distribution positively, negatively, right? I guess many of you would know the story of a shoe company, right? The shoe company sent two market researcher to Africa, okay? And one come back saying, oh no, there's no business for our factory because no one wears shoes in Africa. Okay? And that guy come back say, hey, we have huge business because no one wears shoes and we can sell all shoes to them. Okay? So it really depends on the perspective, whether your glass is half full of half empty, right? It really depends, but still the key thing here is distribution. Okay. Now for the firm, will be the same. Okay, we have a bunch of input prices. The output is depending on the output price and input prices. That is the profit function, right? They're all the price taker. W is exogenous, so W is forget. All right. So that means that you should add up, okay, PS and the W, that will be fine, right? And we don't have the problem of the consumer because of we assume more or less usually firms have symmetric technology, right? Unlike you cannot assume consumer has a similar income level, right? But more or less technology can be considered similar, right? Unless a very special market where people compete in technology, but otherwise everyone can buy a machine and do stuff, right? So it's not the technology difference is not that huge. So that's why it's here. But if you think technology difference is huge, then this model you have to change a little bit. Okay. Now, what is the equilibrium? Okay, in the short run, that no firm can enter exit, so they have to be there. So that means that number of firm denoted by capital J is exogenous fixed. Okay, we are given how many firms we have. No one can enter, no one can exit. Okay, and we define equilibrium in such a way that demand equals to supply. Okay, so that would be our definition. So here you can see I don't say about how this equilibrium comes. Okay, this is just definition of the equilibrium. Okay, you're not saying that if you are not equilibrium, you get to equilibrium. No, equilibrium in our model we just define whenever this happens is equilibrium. So it can be more than one equilibrium. There can be no equilibrium. Okay, and that is not in definition. Definition is just saying that equilibrium defined this way. Okay, and of course you will see this classical definition, right? We'll be saying that this is demand to supply, market demand, market supply. This is where it meets, right? And this is market equilibrium, and where the quantity is here, right? And then if you go back to individual firm, right? This is a short-run marginal cost, short-run average cost. The difference with profit margin, but this is the area is the profit, right? And here, no firm can enter, no one can exit, and they can keep the profit as they want, right? So this is the model, right? And firm don't want to shut down because the price is still higher than the average cost. They make a profit. right? If P is lower than that, right, the market would be gone, right? So no one would do to buy anything, right? So that explains why many shopping center in China, they close down because the price is lower than the online price, right? They can't really, the marginal cost is so high, right? So you can imagine this thing shift up, right? Then you can't really survive, right? So they will exit, shut down, right? And what is the long run equilibrium? Long run equilibrium means that a firm can enter exit. Okay, so which means that the number of firms is endogenously determined, and usually to derive this kind of equilibrium, you assume firms are symmetric, right? Because otherwise the number doesn't mean thing, or you have a set of firms, you know the characteristic, then you can see which one can enter, which one can exit. Okay, in that case, ignoring integer constraint, it will be the case where the profit is 0 or close to 0. That's equilibrium, right? Because we can run to the integer problem, but technically it means that when J is positive, when J plus 1 is negative, then the number of firms is J. So if you want to be precise, right? But is that clear what I'm saying? Okay, so that would be two equilibrium. I mean, you have another equilibrium which is number of firms. So if in the long run, when we will see this compared to that model, because of there are more firms come in, you will drive down the price, so that this happened. Okay, so I think you learned it in undergrad. There's nothing new there. So that's why economists think, okay, if the market is efficient, there's no profit, right? Of course, we know market is not efficient enough. So that's why we can have some profit, right? Because of short run is actually not so short in the real world, right? I mean, for people to come in, there's a lot of entry barrier, right? It takes time to take away those, right? It's not that easy to enter. So that's why people can keep the money, because it takes a very long time to do the long run. Okay, so I guess I should stop here because it's already 3:15. So I guess we go a little bit faster, because these are all you learn equilibrium. We'll ask you to solve equilibrium in your next assignment, but this assignment we just very simple, ask you to do solving some optimization problem. Hope you have enjoyed Mid-Autumn Festival in more mooncake while you're young. If you are as old as me, then probably you can't consume too much mooncake. So enjoy while you can. Have fun. I'll see you next week. Bye bye.